Hey Math 10Cs, today we're going to start systems of linear equations. First lesson, solving systems by graphing. Alright, so a little exploration. The Smith family and the Harper family are going to a book fair raising money for charity. Mr. Smith pays entry fees of $11 for 3 adults and 1 child. Mrs. Harper pays entry fees of $12 for 2 adults and 3 children. We can determine the cost of an adult ticket and the cost of a children's ticket by following 2 linear equations and graphing them. We're going to let X be the entry fee for an adult ticket and Y be the entry fee for a child's ticket. So the Smith family can be modeled by the equation 3x plus y is 11, and the Harper family can be modeled by the equation 2x plus 3y is 12. So draw the graphs of the equations 3x plus y equals 11 and 2x plus 3y is 12 on the grid without using technology. So this will be a good review for your exam tomorrow. You're going to have to know how to graph lines. I want you to pause the recording and graph these 2 lines on the grid at the right. And once you guys are done doing that, you can start the recording again. So here's what we should have had. For the Smith family, the blue line, 3x plus y is 11. All right, we want to solve the equation for y, put it in slope-intercept form. Then we know the slope is -3, the y-intercept is 11. So you make a dot at y-intercept of 11, and the slope rises 3 and runs 1 to the left, or falls 3, runs 1 to the right, and you label that line. For the Harper family, we want to draw this line, 2x plus 3y is 12, solve that equation for y. Now we have it in slope-intercept form. We know the slope's -2/3, the y-intercept is 4, so it crosses the y-axis at 4, has a slope of -2/3, rises 2, runs 3 to the left, falls 2, runs 3 to the right. Draw that line and label that line. So you should have those 2 lines drawn. Now we can answer part B. The graphs of the equations intersect at a point. State the coordinates of this point and explain what the coordinates represent in the context of this equation or this question. So here is the point of intersection of these 2 lines. Those coordinates for that point of intersection are at x is 3 and y is 2. So x is 3, y is 2. So state the coordinates of this point. The point is 3, 2, or you could say x equals 3, y equals 2. What do the coordinates represent? Well, they should represent the price for an adult ticket is $3. That's what x is. Price for an adult, which was x, is $3. And the price for a child, which was y, is $2. All right. So systems of equations. In the exploration on the previous page, we worked with the equation 3x plus y is 11. Now there are many values for x and y that satisfy this equation. We could say when x is 1, y is 8. That works out. 3 plus 8 is 11. We could say when x is 2, y is 5. 3 times 2 is 6, plus 5 is 11. We could say when x is 3, y is 2. 3 times 3 is 9, plus 2 is 11. So all sorts of solutions that satisfy the equation 3x plus y is 11. We also work with the equation 2x plus 3y is 12. All sorts of values for x and y which also satisfy this equation. When x is 0, y is 4. 2 times 0 is 0, 3 times 4 is 12, 0 plus 12 is 12. When x is 3, y is 2. 2 times 3 is 6, 3 times 2 is also 6, 6 plus 6 is 12. There's a whole bunch that work there. However, if we consider both these equations at the same time, there is only one solution that satisfies both. All right? So we're working with both equations at the same time. Only one solution for x and y satisfies both of the equations. So when we consider both equations at the same time, we call that a system of equations. The solution to the system of equations is x equals 3, y equals 2 in this case. That's because those values for x and y satisfy both equations. All right? They satisfy both equations in the system. Graphically, put a big star here. Graphically, the solution to the system is the point of intersection of these 2 lines. So you can find the solution to a system of equations by graphing the lines and finding the point of intersection. So a system of equations has been represented on the grid. The system has an integral solution. Remember, integral has a root word of integer, so it's got values for x and y that are positive or negative whole numbers. State the solution of the system. Well, we're looking for the point of intersection. Looks to be right about here. The coordinates of that point are x is 2, y is negative 1. Those would be the solutions. X is 2, y is negative 1. Write the solutions in order of pair. Well, we did that on the graph. 2, negative 1. Example 2. Consider the system of equations 2x plus y is 2 and x minus 3y is 15. Graph the system without using technology. All right. So I want you again, I would like you guys to do that. Pause the video, graph those two lines, and see what we get. Once you're done graphing, you can start it up again. All right, so the first equation, 2x plus y equals 2. We're going to solve the equation for y, minus 2x from both sides. We now know the slope and the y-intercept. So the y-intercept is 2, slope's negative 2, so you rise 2, run 1 to the left, or fall 2, run 1 to the right. Make sure you identify which line is which, so label that line on the graph. The equation x minus 3y equals 15. Solve that equation for y. So I move the 3y to the other side, and I move the 15 back to this side. So I get x minus 15 is 3y, and then I divide everything by 3. So again, I know the slope, I know the y-intercept, crosses the y-axis at negative 5, has a slope of positive 1/3, so I rise 1 and run 3 to the right. And again, you label that line. Part B says state the solution of the system of equations. Well, the solution is the point of intersection. So label that point that has the coordinates of x is 3 and y is negative 4. All right, so that should be the solution. You can say it as a point on the coordinate plane, 3, negative 4, or you could say x is 3, y is negative 4. I'll accept either answer. Now it says algebraically verify the solution by replacing the values in the original equations. So I've got 2x plus y equals 2. I want to check that one. I also want to check x minus 3y equals 15. Make sure they work in both equations. So all I do is substitute these values, x is 3, y is negative 4, into the equation. 2 times 3 plus y is negative 4 should equal 2. 6 minus 4 equals 2. Yes, it does. Try the second equation. When x is 3, y was negative 4. So negative 3 times negative 4 is a positive 12. 3 plus 12 definitely equals 15. All right. You get a chance to do 1 and 2 in a minute. We're going to continue with the notes. Solving a system of equation using our graphing calculator. So it gives you all the steps here of how to do that. You can read through that. You'll have it for you. We're actually going to do this question with our graphing calculator. All right. So step 1, before you can put anything into a graphing calculator, you have to put the equation in slope y-intercept form, which means we have to solve both equations for y. The only thing on our graphing calculator we have is a y equals button, so we must solve the equations for y. Now, we did that back in that last exploration, so if you recall, this first equation, if I solve that for y, was y equals negative 3x plus 11. And the second equation, when we solved that for y, was y equals negative 2/3 x plus 4. Okay, you could do it again or you can go back and look, but you have to be able to solve the equations for y before you can plug it into our graphing calculator. So that's step 1. Rewrite the equations in slope or intercept form, or rewrite the equations in the form y equals. So the rest of the stuff we'll do with our graphing calculator. So make sure in your y equals screen everything's cleared. And now we can type in the equations that we have. So in y1 I'm going to put that first equation, 3x plus y is 11. But in y equals form, that equation is negative 3x plus 11. In y2, I'm going to type in x minus 3y, 2x plus 3y is 12. Solve that equation for y. We had y was equal to negative 2/3 x plus 4. All right. Now you can see to the left of my y2, the cursor, the line is darker. That's so I can identify which line is which easily. If you want to do the same thing, move your cursor over to the left of the y2 and just hit your enter button and you'll get a whole bunch of different options. Eventually it'll show up to be the darker line, right? You can be shading above, shading below. They can make it follow with a circle, without a circle, dotted line, our regular line, and then eventually get back to our thicker line. All right. Now, it asks you to state a suitable window to make sure you see both the x and y intercepts and the point of intersection. Well, to state a suitable window, the first thing you should always do on your calculator if you're going to graph something is go zoom 6, which is our standard viewing window. And our standard viewing window has a setting of 10 right, 10 left, 10 up, 10 down. So let's do that in our calculator. Let's go zoom, hit your zoom button, and number 6 is standard. It says Z standard, zoom standard. So we just have to hit the number 6, or you can scroll down if you'd like. And now our viewing window is 10 by 10. All right, 10 left, 10 right, 10 up, 10 down. You can see my window setting shows for you guys. So 10 right, 10 left, 10 up, 10 down. Next step. Solve the system of equations using the features of the graphing calculator. So confirm that the entry fees established in the expiration are the same. Well, how do you find the point of intersection on our graphing calculator? You've got the notes above there to tell you. Here's what you do with your calculator. You hit your second function button, which is right here, and then you go to calculate, which is above your trace feature. So above your trace button it says CALC, calculate. Here's your calculate menu. In your calculate menu, we're looking for number 5, the intersection of the two lines. So you hit number 5. You could scroll down to number 5, or you can just hit the number 5, whatever you want. All right. And now it's going to give you some prompts. The first prompt, it says, what's the first curve you want to use to find the points of intersection? So if you notice also in the top left-hand corner, it says y1 is negative 3x plus 11. Yeah, that's the first curve we want, so just press enter. What's the second curve you want? Well, y2 shows up, negative 2/3 x plus 4. Yeah, that's the second curve I want, so press enter. Do I want to make a guess? As you go along in your high school math career, you're going to get curves and lines and all sorts of neat little diagrams that have more than one point of intersection. Well, this system only has one point of intersection, so we don't have to make a guess. We just have to press enter again because there's only one point of intersection. And it now tells us that point of intersection is x is 3, y is 2. All right, you can see the cursor blinking at the point of intersection. X is 3, y is 2. So solve the system. X was 3, y was 2. Confirm the amount of the entry fees established in the exploration. Yes, that's the same as we had in our exploration. All right, so we can use our graphing calculators to solve a system as well. Having said that, anytime you do a question using your graphing calculators, I want to see a rough sketch of what that diagram looks like. We're going to do an example for that real quick. All right. Now, next page here it says, note, if a decimal value appears for the x and or y coordinates, then x and or y can be converted to an exact value as long as it's not an irrational number and within the limitation of the calculator. So it gives you a procedure to use to find the exact value for x. So you exit the graphing screen by pressing clear twice. You press the X key and then the enter key to import the x coordinate. And then you press math fraction to display the answer. All right. For the y coordinate, except for step 2, the instructions to import the y coordinate are the same as above. For step 2, you have to press alpha 1, which means instead of getting the X button, you're going to get the Y button. All right. Maybe this question will help us let us do that. So solve the following system equations using a graphing calculator. So this one's a little bit interesting because this question does not have x's and y's, it's using a's and b's. We're going to solve, doesn't matter what variable I solve for in this equation, but if I'm going to let a equal x and b equal y in my graphing calculator, it's nice to label that for this question so I can keep track of what's going to happen. So in my graphing calculator we have to solve for y. So for these equations I want to solve for b. So this first equation I would minus 6a from both sides and then divide everything by 7. So b would equal negative 6/7 a plus 5/7. Or you could simply write it as this. b equals negative 6a plus 5 all over 7. We don't need to have it in slope-intercept form to put in our graphing calculator. That would be acceptable. All right. For the second equation, again, I want to solve for b. So all I'm going to do is divide both sides by 14. So b should equal 3a over 14. So those are two equations I'm going to type in my graphing calculator. And then I'm going to draw the sketch of the graph in my notes and list the answers, exact values using the technique above. So it will let us do that. All right. So let's graph these in our calculator. Let's go back to your y equals screen. We're going to clear the two equations that we had there. I'm going to type in these two new equations. So 6a plus 7b equals 5. We solved that for b, or we solved it for y. And that gave us negative 6a, but we're going to say negative 6x plus 5, all divided by 7. Now, if you leave it like this, you typed it in incorrectly. This would be the incorrect equation. Not for how we said it, but how we typed it in. What we really should have up here is we should have inserted some brackets. So the numerator must get divided by 7. So negative 6x plus 5 should have brackets around it. And that whole thing should be divided by 7. All right. If you don't want to do that, and you could have typed negative 6 divided by 7 x plus 5 divided by 7. That would have been fine. That's going to give you the exact same line. So if you want to make sure both terms get divided by 7, you can type it in like I put it in y3. If you don't want to divide both terms by 7, then that whole numerator, negative 6x plus 5, must be divided by 7. So your choice, but they're going to give you the exact same line. All right. In y2, we should put that second equation, 3a equals 14b, or if I solve that for b, which was y, we got 3a over 14. So 3x divided by 14. So if you hit graph now, we're going to see our graph. We've got our two lines. Recall how to find the intersection point. You go second, calculate. We've got on number 5, the intersection point. The cursor is on the first equation, y1, so you can press yes. That's the first curve I want, so enter. The second curve is on y2. Yep, press enter. I don't need to make a guess. There's only one point of intersection. And there's my point of intersection, 0.6 repeating and 0.14285714. So let's look to the top of that page 616. In order to find the x-coordinate as an exact value, exit the graphing screen by pressing clear twice. Now it tells us to, I'll clear this home screen too. Now it says press the X button. All right, so that's that button. And then press enter to import the X value. So X was 0.6 repeating. Then it says press math, fraction, number 1. And it'll tell us that 0.6 repeating is the same as 2/3. Repeat this for the Y coordinate. So except for step 2, the instructions are the same. So step 1, yeah, we got it there. We've got clear twice. Step 2 says press alpha 1. So hit your alpha button, and above the number 1 you see in the same color as alpha the letter Y. And you just press enter now. So Y was 0.14285711429. Again, just hit your math fraction button, and it'll tell us what the Y value is as an exact value, and that is 1/7. So X was 2/3, Y was 1/7. We've got that as exact values. X equals 2/3, Y equals 1/7. All right. We could draw a quick sketch of these two lines, like I said we should. So if you look on our graphing calculator, Y1, if you hit the trace feature, the equations show up, and you can move your cursor along each equation. So I'm now on Y1 because that's what's highlighted in the top left-hand corner. So I want to draw that line in my notes. Okay, so let's draw Y1. It looks like it's going something like this. All right, Y1. Not quite. It should be a bit above the, something like that. So that's that equation, 6a plus 7b equals 5. And Y2 is 3a equals 14b. If you look at that one comes over something like this. Maybe a little flatter, but that's 3a plus 4 equals 14b. And we're looking for that point of intersection, which we stated as 2/3 and 1/7. All right. So it's close enough. Now, algebraically verify the solution. All right. So our solution says x is 2/3, y is 1/7. Our original equation didn't have any x's and y's, so what we really should have put here is a is 2/3 and b is 1/7. All right. So let's verify this with a is 2/3 and b is 1/7 back in our original equations. So 6a plus 7b equals 5. Plug a is 2/3. A is 2/3 and b is 1/7. And 6 times 2/3 would be 12 divided by 3, which is 4. And 7 times 1/7 is 1. 4 plus 1 definitely equals 5. So that point satisfies the first equation. Make sure it satisfies the second equation. 3a equals 14b. So 3 times 2/3 should equal 14 times 1/7. 3 times 2/3 is 2. 14 times 1/7 is 2. 2 indeed equals 2. All right. So you guys now do questions 1 through 7. Okay. Where you go.